Multiverse Computing just announced a Series C targeting up to 500 million euros. Here is the complete, verified special coverage. The funding status, who backs it, what HP and Intel are doing, how the compression works, and what I tested. On July 27th, Multiverse announced a Series C targeting up to $570 million, or 500 million euros, at a $1.7 billion pre-money valuation. The company says commitments have arrived to date. Total funding is expected to reach $800 million, including prior rounds, and the round may remain open. The co-leads are Forgepoint Capital International, BNP Paribas Solar Impulse Venture Fund, and Bullhound Capital. Announced commitments also include Santander Alternative Investments, Tikehau Capital, HP, Orange Ventures, Scania Invest, NAventures, Qatar Development Bank, Zouk Capital, SETT, the EIC Fund, the Basque Hazten Fund, and Kutxa. That is strategic, sovereign, industrial, and financial capital converging on edge and efficient AI. HP is more than a logo in the list. HP Tech Ventures joined the 2025 Series B, and HP Incorporated is named again among the 2026 commitments. HP's public venture channel frames the investment around making AI efficient on devices and at the edge. Multiverse also displays HP-branded validation, citing lower time to first token, higher throughput, and 50 to 80% cost and energy savings. Multiverse says models are set for AI PCs. That is a roadmap statement, not a shipping product claim. Intel separately hosts a CompactifAI partner brief for Gaudi 3, based on Llama 3.1 8B testing from April 2025. It reports more than 80% model size reduction, up to 98% accuracy, faster inference through Optimum Habana and VLLM, and lower energy use. Important caveat: Intel says it does not control or audit the third-party data. Then on July 23rd, Multiverse published the newer Xeon 6 result for compressed Llama 3 70B. Disk size fell about 50%. At one user, output throughput rose 93.6% and latency fell 48.6%. At 256 users, throughput rose up to 107% and latency fell 51.7%. While the company reports more than 97% of baseline accuracy retained across benchmarks. Why can this move from accelerators to CPUs and edge devices? The published CompactifAI method first profiles layer sensitivity. Early transformer blocks are more fragile, while middle and later blocks tolerate deeper compression. It selects self-attention and MLP weight matrices instead of shrinking every layer uniformly. Each selected dense matrix is reshaped, then split by sequential singular value decompositions. Only the largest chi correlations are retained, forming a matrix product operator, a chain of smaller tensor cores. Chi controls the compression versus accuracy trade-off. The dense matrix is replaced, then brief retraining, called healing, recovers task quality. I also helped test compressed Llama 3.1 8B in the Deloitte, Intel, and Multiverse AWS study. The public AI4 result was 16 gigabytes to 6.4, 95% more throughput at 128 users, response time from 11.2 to 5.4 seconds, and 49% lower cost per token. The Deloitte white paper documents a state Medicaid policy chatbot in AWS and a federal multi-agent workflow that extracts, classifies, and redacts sensitive entities. GDS Group publicly records our Atlanta model efficiency session. In my separate task level test, the compressed open model matched Claude Opus 4.1 on that document workflow. That is my workload-specific result, not a universal benchmark. Together, this spans agents, models, modalities, and hardware. Next, Multiverse says compressed GLM5.2 is due in about 5 days. The original is already public in its API at $1.10 input and $3.50 output per million tokens. I will test both endpoints under identical quality, latency, throughput, and cost conditions before making any speed claim. Funding explains the scale. Evidence will decide the outcome. Follow for the GLM 5.2 test.